So we are going to now look at a slightly modified version of this architecture and say, or rather a significantly modified version of this architecture and see if I have only one multiplier and adder, how would I go about implementing this filter? Okay, and what I'm going to do is pretty much straight away draw what the final architecture could potentially look like. Okay, what I'm going to assume is that I have one multiplier, the output of that goes to one input of an adder, the output of that adder in turn goes to a register, and the output of this register comes out of the system as well as has a feedback loop going in here. Okay, I am going to just draw one green line over here and also one line over here. We'll get to why those are needed later, right? Those are essentially to sort of be able to reset and break that loop whenever we need it. Okay, but now with this architecture in place, this structure in place, what I am going to say is, now how would you do your filtering? Okay, and one way that I can think about it is, I have the inputs coming in from here. What I need is, at some point in time x of n comes in, at the same time a comes in. Next time instant x of n minus 1 comes in and b comes in here. Next time instant x of n minus 2 comes in here and c comes in here. Okay, right. So the first time around x of n into a, then next clock cycle x of n minus 1 into b, next clock cycle x of n minus 1 into c. What is happening here? X of n into a comes out here, goes through the adder. As long as the register initially has a value of 0, 0 plus a into x of n. Okay, at t equal to 1, I will do that sum, whatever was already there, plus b into x of n minus 1, and at t equal to 2, I will do this sum plus c x of n minus 2. Okay, and at this point I can basically say, take this transfer to output. Right? What should happen at t equal to 3? I should once again do 0 plus a into x of n plus 1. Right? At t equal to 4, I will do that plus b x of n, etc. Okay? So in other words, once in every 3 clock cycles, I will get an output. Okay? So my hardware architecture is now using one multiplier, one adder, one register, right? And there is actually quite a bit of extra support circuitry over here that I have not shown. What kind of support circuitry do I need? I need some shift registers or something that are going to hold the x of n values. That still remains. I have not drawn it over here, but that sort of implicit in this place. Right? I also need some kind of memory that will store my coefficients. I need some kind of a counter that will count 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay. I need a multiplexer out here either feedback or 0, right, which is essentially related to this. So the two green things are essentially related to each other, right. Either I just feed back a 0 to the adder at the appropriate time, that is whenever t is equal to 0 or 3 or 6 or something like that, I feed back a 0 as one of the inputs to the adder, automatically it will update the register correctly at the end of that clock cycle. Or I could reset the register explicitly, okay. But what it means is all of these things that I have marked in red are essentially now supporting circuitry that I have not even shown in the figure. So there is some additional overhead, right. I have got rid of 2 multipliers and 1 adder, yes, but instead, and of course the shift register was anyway required in the other case, but I do have a counter, I do have a multiplexer. That's the very bare minimum additional circuitry that I need, okay. Which one is better? Is this architecture better than the other one? What would you say? It's more flexible, right. On the face of it, one of the things is it looks like it is more flexible. In what ways is it more flexible? Increasing the number of taps now essentially becomes, I could potentially do this without resynthesizing anything, as long as I can change the counter. Instead of counting 0, 1, 2 and then going back to 0, if I can make it go 0, 1, 2, 3, I could potentially just make it do 4 taps or 6 taps or 10 taps, okay. Of course, I will need to have a shift register that correspondingly expands, but shift registers can be implemented in different ways, right. It could be some kind of a separate memory that I look at, which is just designed for the worst case. What it means is that as long as I can provide the memory to store the intermediate values or the past values, I do not really need to worry about how many taps I can implement. I could expand this any way that I like.